let's look at actually laying out these bars in CAD. And this is a drawing that I gave you a handout or whatever it is. Anyway, you have this drawing to practice on if you want. And forgive me, I'll probably bumble around a bit, but we'll just try and get through it. So let's say we have a sample 4-bar linkage and it has these lengths. So these are different lengths than our example and different lengths than our homework problem is just some other numbers. So AB is going to be 3 inches long. CD is going to be 2 inches long and BC is going to be 2 inches long. Okay, and I've drawn these pins and these fixed links. Now, what you know is that these are rigid bars. These are, these are rigid bars. So AB here, you could actually rotate it around that pivot point, couldn't you? And we don't know where it will wind up, but we do know that it rotates somewhere there. So you could draw a circle with the center point on that fixed link and the end point at the end of AB, and this bar AB, wherever it goes, oh, just stop it. Sorry. This bar, see the end point of that bar? It's going to trace a circular path around that circle somewhere. We don't know where yet. And likewise, CD here, we could draw a circle centered at that fixed point with an end point out here at the end of CD. And wherever these things wind up, we do know that CD, see its path there, the end point of that CD has got to trace, it's got to land on that circular path there somewhere. We just don't know where yet. So there are 2 paths that we know for sure. Now, what about when the crank and the connector are stretched out straight? So a 3-inch crank and a 2-inch connector. I saved those as a block. So when that thing is stretched out straight, this is as far as it will go. And you could draw a circle centered at that fixed link with a circumference out here at this end. Oh, sorry. It's really hard to get those O-snaps in there. And this, I saved this as a block. This stretched out length of the crank and the follower will rotate around that point, and the end point of that thing has to land on this big circle somewhere, doesn't it? That's what you get when AB and BC are stretched out straight. We don't know where it will land yet, but it's got to be somewhere on that path. Okay, so what? Now I have down here in this step down here, I've reproduced these things again, and this time, let me erase that one. I have made this big circle, which is the path of this stretched out link, and I have made, and just to be clear, so this link right here, as it rotates, that circle that we just had, that's this circle. I made another circle for link CD. And let me come back up to where I think we're getting confused. So let me come back up here where we had these two stretched out, saved as a block, and we could look at them rotating somewhere around that path. And this link right here, this follower CD, wherever it lands, it's got to stay the same length. So we can now draw a circle with its center at that fixed link and its circumference out here, and CD, this follower, when it rotates, it's got to stay on that little circular path somewhere, doesn't it, wherever it lands. So what you now know is that wherever the big circle and the little circle intersect, that has got to be the far right-hand position of CD, and then these two links stretched out in a straight line. See that? Now what about, and here I've shown that in step 3, what about the other direction? I'll go up here. When the follower CD and the connector BC are stretched out in a line, they are this long. And I could now draw a circle. Oh, so aggravating. Centered there with an end point there. This stretched out thing is going to have to land, oh rats, sorry, base point. These O-snaps are so aggravating. That stretched out two links stuck together, its end point is going to land on that big circle somewhere. We just don't know where yet, when it's in its far left position. And link AB, we could draw another circle representing, golly, where AB is going to go. So its point has to land on that circle somewhere. Therefore, wherever this big circle intersects that smaller circle, that intersection is the position of these links in their far left position. So that's what I was doing there. And down at the bottom here, I have shown you the same idea, but I was getting confused by all these giant circles everywhere, so I trimmed them off and I just left a little short arc so you could see that. Let's see, is there anything else we want to say about these? Yes, we want to say O-snaps are really important, and you saw how I was struggling with O-snaps. You might or might not want to turn off a bunch of these. Maybe turn off quadrant, that seemed to be interfering, and maybe even turn off endpoint temporarily and just keep the center point O-snap so that the darn things, so that you grab the ones that you want to grab. Technically speaking, when you look in the book at the examples he provides, these links do not go all the way to the center of the circle. I don't know. I'm not fussy about that. If you want to just leave these lines going center to center, that is totally fine. Now here is the PDF that I've given you for problem 3 and also for problem 4. So problem 3 has this PDF, which is just a print of this CAD drawing that I made. This is the actual problem 3, and so I've done it again. I've made a big circle that is the crank and the connector stretched out in a straight line, as you can see in step 2 here. And I made a little circle that is the follower link CD. And where the big circle intersects the small circle, as I've shown you here in step 2 and step 3, that's where the extreme right-hand position will be. Then I have, for the left-hand position, I made a circle for crank AB, and I made a big circle for BC and CD, however long they are when they're stretched out in a straight line. I made that circle centered around CD. And wherever those two circles intersect, that's the extreme left-hand position. And then I got my angle dimension, and I dimensioned those two lines. And oh, I don't think that's right. See what you come up with. I think it should be 86, but see what you come up with. I think that's all I have to say about these. Holler if you have questions. Next, we'll go on and look at the slider crank.